The next way to identify the range, the dispersion, is the interquartile range. What is this interquartile range? Let us understand. In interquartile range, the total data set will be divided into two halves. We take the mean from the first half. Mean will be the midpoint of the first half. We also are going to take the mean from the second half, which will be the midpoint of the second half. So these are called Q1 and Q3. What is Q1? Q1 is the mean of the first half, because this will be the 25th percentile. If you actually can understand, when you divide the total data sets into two units, let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, in order to, let us say 1, 2, 3, 4, 5, 6, 7, 8, 9. So this 1, 2, 3, 4, 5, 1, 2, 3, 4 will be the first half, 5, 6, 7, 8, 9 will be the second half. Now the mean will be 2 plus 3 divided by 2 for the first half. This value will be falling under the 25th percent, right? That is, where this mean is going to be present at the total range of the data set at the 25th percent, right? Similarly, the mean for the second half will be falling in 1, 5, 6, yeah, this one. This will be 75th percent. I hope you got a point. The mean for the first half will be available at a position of 25th percent if you take the range from 0 to 100%. The total data points are considered to be spread across 0% to 100%. Okay, so the mean, the first half mean will be falling exactly at the 25th percent. The mean of the second half will be falling exactly at the 75th percent. So mean of the second half will be calculated as, will be termed as Q3. Q3 will called as, mean of the first half will be called as a Q1. Now IQR is just nothing but Q3 minus Q1. Let us understand and demonstrate with an example. Yeah. Yeah, anyhow, have a look at this data set. This data set is from 1, 3, 4, 7, 8, 10, 12, 14, 15, 18, 21. The total data set will be clustered into two halves. One is 1, 3, 4, 7, 8 is the first half. This is the first half. 10, 12, 14, 15, 18, 21 is the second half. Take the first half. Take the mean. What is the mean of the first half? Mean of the first half is 4. What is the mean of the second half? Mean of the second half is exactly not getting intersected at one value. The mean of the second half is actually taking two values in middle. These 14 and 15 actually are the two values which from which we are going to calculate the mean. What is the mean? 14 plus 15 divided by 2. Of course, you got the point. When the data set is even in number, the mean will be the average of mid 2 points. Right? 14 plus 15 divided by 2 is equal to 14.5. But in order to make it simple, I just am rounding it off to the next positive integer. The mean for the second half is considered to be as 15. The mean for the first half is equal to 4. The mean for the second half is called as a Q3 because it is falling at the 75th percentile. 75th percentile will be falling under quarter 3. And this 4 will be falling under, this is 25th percent, 25th percent will be falling under Q1. This is called Q1. This is quarter 1 and this is first quarter and this is the third quarter. So when you divide, when you subtract Q1 from Q3, that is Q3 minus Q1, you will get IQR. Okay. Here, median of the second half is 15, median of the first half is 14. 4. 15 minus 4 is equal to 11. This is another way of calculating IQR. Sorry, this is another way of calculating the range. Okay. In the next session, we are going to discuss about mean absolute deviation. Okay. So what is this mean absolute deviation? Let us understand. the mean absolute deviation, directly we'll calculate the mean absolute deviation, then we will talk about why mean absolute deviation is going to be used. What is mean absolute deviation? For that, let us take a data set, 48653. The data set contains 5 values and you take the mean. Mean is, sum divided by the total data points. Sum is 26, data points is equal to 5, that is equal to 5.2. 5.2 is the actual mean. Now we just need to find out the absolute deviations. What is an absolute deviation? Absolute deviation is the deviation without the negative sign. So what do? In order to avoid a negative sign, we just are going to subtract and mod it. Each and every data point, rather, this mean should be subtracted from every data point. Okay, that is 4 minus 5.2. 4 minus 5.2 will give you a negative value. Yes or no? In order to avoid that negative value, we are going to mod it. When you apply the mod rule, the negative sign will be avoided. And again, 5.2 must be subtracted from 8. Okay, so then it is going to give you minus 2.8. 4 minus 5.6, this is minus, yeah, anyhow. 8 minus 5.2 is equal to plus 2.8. 6 minus 5.2 is equal to 0.8. 5 minus 5.2 is equal to minus 0.2, right? That will, when you apply the mod, the negative signature will be removed. 3 minus 5.2 is equal to minus 2.2, it will become positive 2.2. When you add them and take the average, you are going to get MAD, mean average deviation. Okay. That is what our mean absolute deviation. Once again, we need to collect the mean. We need to subtract every data point from the mean. The value will be either positive or negative. In order to avoid the signature, we just are going to apply the mod rule. Right then we need to add all the values and divide it by n. That is going to be your mean absolute deviation. This is also one of the other approach to calculate or to get the range of the data points that are spread across the mean. Thank you.